Hello everyone, my name is Franco Pucci. I'm the technical consultant for the STS Association and I've been involved in the prepayment industry for over 25 years. Welcome to the STS training video series where we will explore all aspects of the STS and the STS standard. I hope you find these videos helpful. In this section we will deal with international specifications, the IEC 62055-41 application layer protocol mainly, the IEC 62055-51, the physical layer protocol, and the IEC 62055-52 two-way token carrier protocol we won't deal with in this video series, but they will come in a later series. So in this video we will deal with section 6 of the IEC 62055-41. That's data elements of the ADPU definitions. The reference source is obviously the document itself. So without much further ado, let's start with the meter pan. So the meter pan, or the primary account number, is described in clause 6.1.2. And if we have a look at the elements of the meter pan, you have the IIN, or the issuer identification number, which defines the domain of the payment meter. The format is 4 or 6 digits and it's shown in red, and if you look at the example for a 2-digit manufacturer code underneath, you will see that it's 600727. The IIN for a 2-digit manufacturer code is always 600727. For a 4-digit manufacturer code, however, the IIN is always 0000. And that's because we needed 2 extra digits for the manufacturer code, so we decided to make the rest zeros. Then you have the DRN number in black, which is the meter number, or decoder reference number as it's known, and that's either 11 or 13 digits. Then you have a check digit in yellow, that's based on the Lund formula, and it is a result of a formula to check the integrity of the IIN and DRN together, and that is 1 digit. The decoder reference number itself, or DRN, is described in 6.1.2.3. That consists of a manufacturer code, which is allocated by the STS Association, and that's either 2 digits or 4 digits, as you can see in the 2 examples below. You have the decoder serial number, which is allocated by the manufacturer of the meters, and that's 8 digits. Then you have the check digit once again, which is a result of a Lund formula, and that's a single digit. Please note that the combination of manufacturer code and serial number makes all DRN numbers unique, even if the serial number is duplicated between manufacturers. And that's because the manufacturer number at the beginning limits that sequence of numbers per manufacturer. Token carrier type, another definition, and that's found in clause 6.1.3. There are 4 token carrier types defined in the standard. Token carrier type 01 is for a magnetic card, and that you can find more details in 62055-51. Token carrier type 02 is for a keypad, which most meters are today, and you can also find that in the same document. And then there's token carrier type 07, which is a virtual token carrier for direct connection to the meter, and it's 2-way, so the meter could talk back on that same token carrier. And details on that you can find in IEC 62055-52. The latest one to be defined is virtual token carrier type TCT08, which is the LMS COSM token carrier, also a direct link to the meter, and also a 2-way token carrier. For the specifications relating to that token carrier, you can look at STS 101-2 and STS 201-2. All others are reserved or proprietary, and they are currently not used. Decoder key generation algorithm, or DKGA, that is described in clause 6.1.4. You have a DKGA 01, which is in legacy systems and is very limited use, and it should not be used on new designs. DKGA02, which is the current system for over 70 million meters. It's a 64-bit DES vending key generation, and it's currently in use, but it will be phased out by 2024. all new designs should be using the next one, which is DKG-A04. That's a 256-bit KDF vending key generation algorithm. It's currently in use, and all new systems should use this because the others do not support the TID rollover program. All other DKG-A codes are reserved or proprietary and should not be used. Please note that the TID rollover program must use DKG-A04. DKG-A02 will be phased out by 2024 since it does not support multiple base states. The encryption algorithm, clause 6.1.5, there are 3 associated codes: 07, which is STA, which is the one currently in use for all legacy systems. It may be used for new designs if you so desire. 09 is a 64-bit DES encryption algorithm. It's not used. Do not use this for new designs. It will probably be removed in the next edition of the 41 specification anyway. And then you have EA11, which is the MISTY one, 128-bit algorithm. This may be used for new designs if you so wish, and all others are reserved. Please note that MISTY 1 can only be used in conjunction with DKG-A04 and not 02. STA may be used with DKG-A02 or DKG-A04. Let's just talk a little bit about supply group codes, or SGCs. And for that you can look at clause 6.1.6 and also STS 401-1. A supply group code is a 6-digit number allocated by the Key Management Center for use by an SGC user for the geographical demarcation of a group of prepayment meters and associated with a vending key. It is not the vending key, it is associated with the vending key. The SGC is owned by the STS Association. Okay, so remember, a supply group code is not a vending key, but has a vending key associated with it of type VDDK, the default vending key, VUDK, a unique vending key, or a VCDK, a common vending key. Each meter within the supply group code has a unique decoder key generated using these vending keys, thereby allocating the meter to a particular supply group code. Although the STS Edition 2 allows for the use of 10 digits for a supply group code, only 6 have been currently specified in IEC 62055-41. There may come a time where we need to specify 10, probably in the next revision of the specification. Tariff index you can find in clause 6.1.7. This is a 2-digit number in the range 1 to 99 associated with the tariff allocated to a particular user. Encoded into the decoder key, the tariff index is, and if the tariff index changes, so does the decoder key, but the SGC remains the same. So if you want to change keys in a meter, but you do not want to change the supply group code, all you need to do is change the tariff index. Key revision number, clause 6.1.8. This is a 1-digit number in the range 1 to 9 that uniquely identifies a vending key within a supply group code. Again, you can change the key revision of a vending key and leave the supply group code the same, which will result in all the meters associated with that SGC changing their keys. If the KRN changes, so does the vending key, but the SGC remains the same. Okay, that's quite important. So you may want to leave your supply group code the same, but change the meter keys, in which case you just change the key revision number. And that is the reason why the key revision number now is going up for the rollover, for the TID rollover program, because we want to leave the SGCs as they are, but change all the vending keys, change all the decoder keys in the meters. Please note that the KRN is not linked to a base date, but when the base date does change, so will the KRN. So it does not mean that if your KRN changes, so has the base date. It does mean that if the base date changes, so has the KRN changed. And this brings us to the end of this short video. I hope you found this video helpful and hope you will join us for the rest of the series. Goodbye and see you again soon.